You're joining us today for a focused exploration, maybe a shortcut, to understanding the essentials of the AWS Cloud,
hmm
our source material. The AWS Certified Cloud Practitioner, CLF-C02 Exam Guide.
Yeah,
Think of this as your personal briefing, really. We're pulling out what AWS sees as foundational knowledge so you can get a handle on the core concepts quickly.
that's right. And this certification, so our discussion today, it's really designed with you in mind, anyone who needs that solid understanding of AWS Cloud.
Right.
Whether you're technical, maybe working alongside cloud teams, but not technical yourself or just curious, this gives you that baseline.
Okay.
We'll be looking at what AWS offers, how security works, that shared responsibility model, cloud costs, billing, the main services, common use cases, all that stuff.
So who exactly is AWS thinking about for this exam? The guide says it's someone with, like, 6 months of AWS exposure.
Roughly. Yeah.
Now, that could be hands-on, maybe design or implementation. But interestingly, it also includes folks from non-IT backgrounds. So if you're relatively new to the cloud, or maybe you collaborate with people who are deep in it, this seems, well, pretty relevant for you.
And it's just as important to know what's not covered, right?
Yeah.
For this exam, we're not digging into coding or deep cloud architecture design.
Okay.
Complex troubleshooting, implementation details, load testing, performance testing, none of that.
Yeah.
So if those areas seem a bit intimidating, you can kind of relax, knowing they're out of scope here.
That is definitely good to know. Now, let's talk about the exam itself. What can someone expect?
Mhm.
The guide mentions 2 main question types: multiple choice, pick 1 from 4 options,
Standard stuff.
and multiple response, where you'll pick 2 or more correct answers from, like 5 or more options.
Yeah.
And here's a useful point: no penalty for guessing wrong.
Which is always nice.
You'll see 50 scored questions and then 15 unscored ones that AWS uses, for developing future exams.
Yeah, testing out new questions and scoring. It's on a scale, 100 to 1,000. 700 is what you need to pass. It's just an overall pass-fail result. And the guide mentions a compensatory scoring model.
What does that mean exactly?
Well, what that means for you is you don't have to ace every single section. Your total performance across the board determines if you pass or fail.
Got it. Makes sense.
Yeah.
Now, to make this deep dive manageable, the exam content is split into 4 main domains, each with a specific weight.
Yep.
First, domain 1, cloud concepts. That's 24% of the score.
Okay.
Then domain 2, security and compliance. That's a bigger chunk, 30%.
Right, really important.
Domain 3 is cloud technology and services. That's the largest bit, 34%.
The core tech.
And finally, domain 4, billing, pricing, and support, making up the last 12%.
Exactly. Keeping those percentages in mind kind of gives you a feel for where the exam and, well, our chat today will focus most.
Right.
Our mission here is basically to break down each domain, pull out the key concepts from that exam guide that you really need to understand. So let's jump into that first one, cloud concepts.
Okay. Domain 1, cloud concepts. First task statement: define the benefits of the AWS cloud. The guide lays out some core ideas, starting with the value proposition. What's the basic offering here?
Well, at its heart, it's about giving you IT resources,
Yeah.
Servers, storage, databases on demand over the internet, and you only pay for what you actually use.
Pay as you go.
That pay-as-you-go thing leads right into economies of scale. Think about it. AWS buys and runs infrastructure at a massive scale, way bigger than most companies could ever manage.
Sure.
So that bulk purchasing power means they can offer services cheaper than you could likely do it yourself. That cost saving is a pretty big advantage.
Makes sense. Buying in bulk helps everyone.
Mhm.
The guide also talks about global infrastructure. How does that help someone using AWS?
The fact that AWS has data centers dotted all over the globe means you can put your apps and services closer to your users wherever they are.
Lower latency.
Exactly. Lower latency, faster deployment times. It just makes for a better user experience. Plus, that global reach gives you resilience and helps meet local regulations if you need to.
And then we have those classic cloud benefits: high availability, elasticity, and agility. Let's unpack those a bit.
Sure. High availability just means your apps and data should be accessible with very, very little downtime. AWS designs its infrastructure with redundancy built in to handle failures.
Okay.
Elasticity, that's the ability to automatically scale resources up or down based on demand. So your website gets slammed with traffic, AWS adds capacity
But
automatically.
you only pay for it when you need it.
Precisely.
Yeah.
When the surge passes, it scales back down. And agility is all about speed and flexibility. You can spin up resources fast, try new things, adapt way quicker than with old school on-prem setups.
All right, now let's look at task statement 1.2. Identify design principles of the AWS cloud. This brings up the AWS well-architected framework. What's the main idea behind this?
The well-architected framework is essentially a set of best practices, a guide, really, to help you design and run systems in AWS that are secure, high-performing, reliable, and cost-efficient.
It's like a checklist.
Kind of, yeah. It gives you a consistent way to look at your cloud setups and see where you might be able to improve things.
And the guide mentions its pillars. What are these different viewpoints for evaluating cloud systems?
There are 6 pillars. First, operational excellence. That's about running and monitoring your systems well, delivering business value, constantly improving processes.
Okay.
Second, security. Protecting your info and systems, understanding your security posture, using AWS tools to boost security. Third, reliability. Can your system recover from problems, handle demand automatically, deal with failures?
Makes sense. That's 3. What are the other 3?
Fourth is performance efficiency. Using your computing resources effectively to meet requirements and keeping it efficient as things change. Fifth, cost optimization. Avoiding waste, always looking for ways to cut costs without hurting performance or security.
And the newest one.
Right. The 6th pillar is sustainability. This is about minimizing the environmental footprint of your cloud workloads, focusing on energy efficiency, and using fewer resources. So this framework gives you a structured way to think about all these important aspects when you build on AWS.
So the well-architected framework gives you that structured approach, covering operations, cost, even environmental impact. Okay, next up is task statement 1.3. Understand the benefits of and strategies for migration to the AWS cloud. Why would an organization even, move to the cloud?
Well, the benefits are huge. We've touched on some, saving money, being more agile, but the guide specifically calls out the AWS Cloud Adoption Framework, or AWS CTAF.
Okay, CF.
Yeah, this framework helps organizations think through all the different parts of a cloud move, not just the tech side.
And what kind of benefits does CF highlight?
It talks about things like reduced business risk, using AWS's built-in security, also improved ESG, environmental, social governance performance thanks to AWS's sustainability focus. Business-wise, it aims for increased revenue through new cloud services and increased operational efficiency because AWS handles a lot of the underlying grunt work for you. So it's not just tech, it's about the bigger business picture.
Right, it's the broader impact. And what about the actual process of moving? What kind of migration strategies are there? The guide mentions a couple.
Yeah, it specifically mentions database replication. That's where you continuously copy data from your old database to one in AWS before you make the final switch. Makes for a smoother cutover, less downtime.
Okay.
It also mentions using AWS Snowball. Think of it like a rugged physical hard drive AWS ships to you. You load it with tons of data, ship it back, and they load it into the cloud. Really useful if your internet connection isn't great for transferring huge amounts of data.
Right, like SneakerNet for the cloud.
Kind of, yeah. These are just examples, though. The best strategy really depends on what exactly you're moving.
Okay, that leads nicely into task statement 1.4. Understand concepts of cloud economics. How does the money side of cloud differ from traditional IT?
The big difference is shifting from mostly fixed costs, those big upfront payments for hardware and data centers, to more variable costs in the cloud. You pay for what you use.
CapEx to OpEx.
Exactly. Capital expenditure to operational expenditure. The guide also wants you to think about all the costs of running things on premises: hardware, power, cooling, IT staff salaries. These often get underestimated when comparing to cloud prices.
Right, those hidden costs add up. The guide also mentions licensing strategies, specifically bring your own license, BYOL, versus included licenses. Can you explain that?
Sure. BYOL means you use your existing software licenses, maybe for Windows Server or SQL Server in the AWS cloud. Could save you money if you already own them.
Okay.
With included licenses, the cost of the software license is just built into the price of the AWS service, like an RDS instance, so you don't need a separate license. Which is better, depends on what licenses you have and the service you're looking at.
Another concept mentioned is right-sizing. What does that mean for my cloud resources?
Right-sizing is just about picking the right size and type of virtual server, what AWS calls an instance type for your specific job. It's key for controlling costs.
So not too big, not too small.
Exactly. You don't want to overpay for capacity you don't use, but you also need enough power. The cool thing about the cloud is you can adjust this easily as your needs change.
And the guide points out benefits of automation, mentioning AWS CloudFormation. How does automating stuff help with costs?
Automation, using tools like CloudFormation, which lets you define your infrastructure as code cuts down on manual effort and potential mistakes when setting up and managing your environment.
Fewer errors, less time spent.
Right. That saves money through less labor and more efficient resource use.
Finally here, it mentions managed AWS services like Amazon RDS, ECS, EKS, DynamoDB. How do these fit into cloud economics?
Managed services basically take away a lot of the day-to-day operational headaches of managing the underlying infrastructure. Like with RDS, the managed database service, AWS handles patching, backups, scaling for you.
This frees up your team.
Exactly. Your team can focus on your applications, not babysitting databases. While there's a cost for the managed service itself, the reduced operational overhead often leads to overall cost savings. Okay, let's shift gears into domain 2, security and compliance. This was, what, 30%? Big chunk.
Yeah, 30%.
And the first task here is absolutely fundamental. Understand the AWS shared responsibility model. You really need to get this.
Absolutely. So, in simple terms, what's the deal with this model?
It clearly lays out who's responsible for what. AWS is responsible for security of the cloud, the physical data centers, the network hardware, the core software making it all run.
So, AWS secures the platform itself. What are my responsibilities then as the customer?
You, the customer, are responsible for security in the cloud. That means securing your applications, your data, setting up firewalls correctly, managing user access, patching operating systems and apps on servers you control, like EC2 instances.
Okay, so I handle what I put on the cloud. The guide mentioned shared responsibilities too. Give me an example of that.
Yeah, patching is often shared. AWS patches the infrastructure underneath a service, but you patch the guest operating system and any apps you installed on, say, an EC2 instance. Configuration is another one. AWS provides secure building blocks, but you have to configure things like security groups correctly.
Right. The guide also points out that responsibilities shift depending on the service, mentioning RDS, Lambda, and EC2. How does it differ for those?
Good point. With Amazon EC2, you manage almost everything on the instance OS patching, security software, firewall rules. You have more responsibility.
Maximum control, maximum responsibility.
Pretty much. With AWS Lambda, the serverless compute service, AWS manages almost everything but your code. Your main job is securing your code and its permissions. Amazon RDS, the managed database, is somewhere in between. AWS manages the infrastructure and OS, but you're still responsible for managing database user access, maybe network access controls, and sometimes aspects of database patching depending on the engine.
That makes sense. The more AWS manages for me, the less operational security burden I have for the underlying bits. Okay, next. Task Statement 2.2. Understand AWS cloud security, governance, and compliance concepts. Sounds broad.
It is. It starts with AWS compliance and governance concepts. Basically, AWS gets a ton of compliance certifications like ISO 27001, SOC2, PCI DSS.
And industry standards.
Exactly. This shows they meet various security standards, which can really help you meet your own compliance needs when you build on AWS.
And where can I find proof of these certifications? The guide mentions AWS Artifact.
Yep, AWS Artifact is the place to go. It gives you on-demand access to AWS's compliance reports, SOC reports, PCI attestations, all that stuff. You can download them to show your auditors or just understand how AWS meets certain rules.
Okay.
The guide also stresses understanding compliance needs based on geography or industry and points to the AWS compliance website as a resource.
So, depending on where I operate or my industry, I'll have specific rules, and AWS helps me figure out how their services fit.
Got it. It also talks about benefits of cloud security, highlighting encryption.
Absolutely. Encryption is fundamental. It protects your data, both when it's moving between systems that's in transit and when it's just sitting there stored at rest.
Okay.
The guide wants you to know there are different encryption options, like using TLS SSL for data in transit, and services like AWS KMS Key Management Service or S3 server-side encryption for data at rest.
And if I need to investigate something, where do I find security logs?
Key spots are Amazon CloudWatch logs for application and system logs, and AWS CloudTrail, which logs basically every API call made in your account. Knowing where to look is crucial for monitoring and investigations.
The guide lists several customer security tools. Amazon Inspector, AWS Security Hub, Amazon Guard Duty, AWS Shield. What do these help me with? Okay, quick rundown. Inspector scans your EC2 instances and containers for vulnerabilities. Security Hub gives you a central dashboard view of all your security alerts and compliance status across your accounts.
Like a command center.
Kind of. Guard Duty is a threat detection service. It constantly looks for malicious activity or weird behavior in your account. And AWS Shield is managed DDoS protection. Distributed denial of service helps stop attacks trying to flood your applications.
Sounds like a solid toolkit AWS provides. The guide also mentions services for governance and compliance beyond just security tools. CloudWatch, CloudTrail, AWS Audit Manager, AWS Config, Access Reports. How do these help?
Right. CloudWatch is for monitoring and observability. CloudTrail, as we said, logs API calls for auditing. AWS Audit Manager helps you continuously audit your AWS usage against compliance standards. AWS Config tracks changes to your resource configurations over time, great for compliance and troubleshooting. And Access Reports help you see who has access to what.
Finally, for this task, the guide says compliance requirements vary among AWS services. Why is that important?
Well, different services handle data differently. A database service like RDS will have different compliance considerations than, say, a compute service like Lambda. So you need to understand the specific compliance aspects of the services you choose to use. Okay, let's move to task statement 2.3. Identify AWS access management capabilities. This is mostly about AWS Identity and Access Management, or IAM. Super important for controlling who does what.
Right. IAM is key for permissions. The guide really stresses protecting the AWS root user account. Why is that so critical?
The root user is, well, the God account. It has complete unrestricted access to everything in your AWS account. If those credentials get compromised, it's game over.
Yikes.
Yeah. So best practice number 1, lock down that root account with a super strong password, enable multi-factor authentication, MFA, and don't use it for everyday tasks. Seriously.
Got it. Use it only when absolutely necessary. The guide also mentions the principle of least privilege. What's that about?
Least privilege means you only give users and services the absolute minimum permissions they need to do their specific job and nothing more.
Don't give everyone admin rights.
Exactly. It drastically limits the damage an attacker could do if an account gets compromised. Always grant only the permissions needed.
We also see AWS IAM Identity Center mentioned, which used to be AWS Single Sign-On. What's its role?
IAM Identity Center gives you a central place to manage user access across multiple AWS accounts and even some cloud applications. It makes managing users easier and helps enforce consistent security policies. Plus, it integrates with existing identity providers.
Speaking of managing access, the guide brings up access keys, password policies, and credential storage using AWS Secrets Manager and AWS Systems Manager. How do these fit in?
Okay, access keys are long-term credentials for programmatic access using the API or CLI. Use them carefully, rotate them often. Password policies let you enforce rules for user passwords like length, complexity, rotation frequency.
Makes sense.
AWS Secrets Manager helps you securely store and retrieve sensitive stuff like database passwords or API keys so you don't hard-code them in your apps. Systems Manager Parameter Store can also store configuration data and secrets securely.
And what about authentication methods? The guide lists MFA, IAM Identity Center, and cross-account IAM roles. How do these verify identity?
MFA, multi-factor authentication, adds that extra layer of security. You need more than just a password, maybe a code from an app or a hardware key. Makes it much harder for bad actors.
Like 2FA for your bank account.
Exactly like that. IAM Identity Center provides that central login point we discussed. Cross-account IAM roles let users or services in one AWS account securely access resources in another account without sharing long-term keys. Very useful for managing multi-account setups.
The guide also asks us to define groups, users, custom policies, and managed policies in IAM, linking back to least privilege. How should I think about these building blocks?
Okay, IAM users are individual people or services needing access. IAM groups are just collections of users, makes it easy to manage permissions for multiple people at once. IAM policies are the documents that actually define what permissions are granted. Managed policies are pre-built policies created and maintained by AWS for common use cases. Custom policies are ones you write yourself for very specific needs. When setting these up, always think, what's the minimum permission needed here? That's least privilege in action.
Are there things that only the root user can do?
Yes, a few critical account level tasks. Things like closing the AWS account entirely, changing the root user's email address, managing certain support plan details. Another reason to guard those root credentials carefully.
And what are the practical methods to protect the root user that I should absolutely do?
Top priorities. Use a very strong, unique password. Enable MFA non-negotiable. And don't use the root user for anything other than those specific root-only tasks. Create separate IAM users with limited permissions for all your day-to-day work.
Lastly here, types of identity management, specifically federated identity. What's that?
Federated identity lets your users log into AWS using credentials they already have, maybe from your company's directory, like Active Directory.
Single sign-on.
Yeah, basically, you don't have to create and manage separate IAM users for everyone. It simplifies user management and leverages your existing identity system.
Okay, last task in domain 2. Identify components and resources for security. The guide mentions security capabilities AWS provides and where to find security documentation.
Right. AWS has tons of security features built in. For documentation, key places are the security pillar of the well-architected framework, security white papers on the AWS site, and the security sections within the documentation for each specific service. Very valuable resources.
And it asks us to describe specific AWS security features like security groups, network ACLs, and AWS WAF. How do these protect my stuff?
Security groups are like firewalls for your individual EC2 instances. They control inbound and outbound traffic at the instance level. Network ACLs, access control lists, are also firewalls, but they operate at the subnet level within your VPC, controlling traffic in and out of entire network segments. AWS WAF, Web Application Firewall, protects your web applications from common web attacks like SQL injection or cross-site scripting by filtering traffic based on rules you define.
It's also good to know that third-party security products are available from AWS Marketplace. What can I find there?
Yeah, the marketplace is huge. It offers a ton of security solutions from other companies that complement AWS's own services. Think advanced firewalls, intrusion detection systems, vulnerability scanners, specialized compliance tools, lots of options to meet specific security needs.
Where can I find more AWS security info to stay current? The guide points to the AWS Knowledge Center, AWS Security Center, and AWS Security Blog.
The Knowledge Center is great for answers to common questions, including security ones. The AWS Security Center is a dedicated portal for security news, alerts, and best practices from AWS. And the AWS Security Blog has in-depth articles from AWS security experts on current topics and services. Definitely worth following.
Lastly in this domain, using AWS services for identifying security issues, specifically AWS Trusted Advisor. How does that help?
AWS Trusted Advisor scans your AWS environment and gives you recommendations across several areas, including security. It checks for things like overly permissive security group rules, IAM best practices, MFA on the root account, and other potential weaknesses. It helps you proactively spot and fix security issues. All right, let's dive into the biggest domain, domain 3, cloud technology and services at 34%. Task 1 here. Define methods of deploying and operating in the AWS cloud. How do I actually get things running on AWS?
Yeah, what are the main ways to interact with AWS?
You've got several options. Programmatically, you can use the APIs, the SDKs, software development kits for different languages like Python or Java, and the CLI command line interface.
For scripting and automation.
Exactly. For a visual approach, there's the AWS Management Console, the web interface. And for managing infrastructure as code, you'd use tools like AWS CloudFormation or the AWS CDK Cloud Development Kit.
The guide contrasts one-time operations versus repeatable processes. Why does that matter in the cloud?
Well, in the cloud, especially for infrastructure, you really want to aim for repeatable processes through automation. It ensures consistency, reduces manual errors, makes scaling easier.
Instead of clicking around in the console every time.
Right. Relying on manual one-time operations is just prone to mistakes and inconsistencies, especially as things get more complex. Automation is key.
And what about the different cloud deployment models?
The main ones are cloud, where everything runs in AWS. Hybrid, a mix of cloud and your own on-premises gear. And on-premises, the traditional model where you manage everything yourself in your own data centers. Understanding these helps you pick the right strategy.
Finally here, connectivity options. How do I connect to my AWS resources?
The common ways are the public internet, which is how you access many services by default. AWS VPN sets up a secure encrypted tunnel between your office or data center and your AWS Virtual Private Cloud, VPC, over the internet. And AWS Direct Connect gives you a dedicated private network connection straight into AWS, bypassing the public internet.
Okay, moving to task 3.2. Define the AWS global infrastructure. This is about regions, availability zones, and edge locations. How do these pieces fit together?
Yeah, this is fundamental to how AWS provides reliability and scale. AWS regions are separate geographic areas around the world. Think North Virginia or London or Tokyo.
Big geographic footprints.
Right. Within each region, there are multiple isolated availability zones, or AZs. An AZ is basically one or more distinct data centers with redundant power, networking, and cooling. They're physically separate within a region to provide fault tolerance.
So if one AZ has a problem, the others in the region keep running.
That's the idea. And edge locations are a separate network of points of presence, globally distributed, used by services like Amazon CloudFront to cache content closer to users for better performance.
The guide emphasizes high availability and using multiple regions. How does the infrastructure enable that?
By deploying your application across multiple AZs within one region, you achieve high availability. If one AZ fails, your app keeps running in the others. Using multiple regions gives you even higher availability and disaster recovery. If an entire region goes offline, you can potentially fail over to another region. It also helps with low latency for global users and data sovereignty rules.
And it mentions that availability zones don't share single points of failure. Why is that isolation important?
It's key for reliability. Each AZ is designed to be independent regarding power, cooling, physical security. So a fire or a flood or a power outage in one AZ shouldn't take out another AZ in the same region. It boosts the resilience of applications spread across them.
We also have the benefits of edge locations, especially for Amazon CloudFront and AWS Global Accelerator. How do they use these edge spots?
CloudFront uses the edge locations as a content delivery network, CDN. It caches your static content images, videos, website files at these locations close to your users. So when a user requests that content, it's served from the nearby edge location, which is much faster.
Lower latency again.
Yep. AWS Global Accelerator uses the AWS Global Network and these edge locations to find the best path for user traffic back to your application endpoints running in the main AWS regions. It improves performance and availability by optimizing the network route.
The guide briefly mentions AWS wavelength zones and AWS local zones. What are these?
These are newer infrastructure types for specific needs. Wavelength zones embed AWS compute and storage inside the 5G networks of telecom providers. They're designed for ultra-low latency applications, think mobile gaming or AR/VR.
Okay, really close to the mobile user.
Exactly. AWS local zones are extensions of a main AWS region, but physically located closer to large cities or industrial centers. They let you run latency-sensitive parts of your applications nearer to end users in those specific metro areas without needing a full new region there.
Finally here, understanding the relationships among regions, AZs, and edge locations. Summarize that picture for me.
Okay, think of regions as the large, distinct geographic areas. Within each region, you have multiple availability zones, providing the high availability and fault tolerance inside that region. Edge locations are then spread out even more globally, acting as the front-end delivery points for services like CloudFront and Global Accelerator, reducing latency for users everywhere.
Got it. Let's move to task 3.3. Identify AWS compute services. What are my main choices for running code and applications?
The core compute options are Amazon EC2, Elastic Compute Cloud, that's your virtual servers in the cloud. Then you have container services like Amazon ECS, Elastic Container Service, and Amazon EKS, Elastic Kubernetes Service, for running Docker containers. And finally, serverless compute like AWS Fargate, which runs containers without managing servers, and AWS Lambda, which runs code in response to events.
The guide mentions recognizing appropriate use of EC2 instance types, like compute optimized or storage optimized. How do I choose?
AWS has a whole zoo of instance types optimized for different jobs. Compute-optimized instances have powerful CPUs, good for things like scientific modeling, batch processing, or game servers. Storage-optimized instances have fast, high-throughput local storage, great for databases, data warehousing, or distributed file systems. You need to match the instance type to your workload's needs, CPU, memory, storage, network, to get the best performance and cost.
And when would I use containers with ECS or EKS? What's the benefit?
Containers package your application and all its dependencies together, making it portable and consistent. ECS is AWS's own managed container orchestrator, generally simpler to get started with. EKS is the managed Kubernetes service, offering the power and flexibility of Kubernetes, which is great for more complex microservices architectures. Containers help with faster deployments, better resource utilization, and consistency between development and production.
What about serverless with Fargate and Lambda? When are they a good fit?
Fargate lets you run containers without worrying about the underlying EC2 instances at all. AWS manages the infrastructure. Great for simplifying container operations. Lambda lets you run code snippets triggered by events like an 80 file upload to S3 or an API call without provisioning any servers. You only pay for the milliseconds your code runs. Ideal for event-driven tasks, APIs, or things that don't run constantly. Serverless massively reduces operational overhead.
The guide also says auto-scaling provides elasticity. How does that work with compute?
Autoscaling automatically adjusts the number of EC2 instances or container tasks you have running based on demand, defined by metrics like CPU utilization or request count.
So it adds more servers when busy, removes them when quiet.
Exactly. It ensures you have enough capacity to handle load, but you're not paying for idle resources during quiet periods. That's the elasticity matching resources to demand automatically.
Finally, the purpose of load balancers. Why use one?
Load balancers sit in front of your compute resources, like a group of EC2 instances, and distribute incoming traffic across them. This prevents any single instance from getting overloaded, improving availability and fault tolerance. They also typically perform health checks, only sending traffic to healthy instances, essential for reliable applications.
Moving on to task 3.4, identify AWS database services. What kinds of databases does AWS offer?
AWS has a broad portfolio. For relational databases, you've got Amazon RDS, which supports popular engines like MySQL, PostgreSQL, SQL Server, Oracle. And there's Amazon Aurora, AWS's own high-performance relational database compatible with MySQL and PostgreSQL. For NoSQL, the big one is Amazon DynamoDB, a highly scalable key value and document database. They also have in-memory databases like MemoryDB for Redis, for caching and low-latency access, and graph databases like Neptune.
The guide asks about EC2 hosted databases versus AWS managed databases. What are the trade-offs?
If you run a database yourself on an EC2 instance, you have total control, but you're responsible for everything: installation, patching, backup, scaling, high availability. It's a lot of work.
The heavy lifting.
Right. With managed databases like RDS or Aurora, AWS handles most of that operational burden for you. It's much easier to manage, often more reliable and scalable, but you might give up some fine-grained control over the underlying OS or database configuration. Usually the managed option is preferred unless you have very specific needs.
The guide also mentions database migration and tools like AWS DMS and AWS SCT. How do these help move databases to AWS?
AWS DMS, Database Migration Service, helps you migrate databases to AWS with minimal downtime. It can replicate data from your source database while it's still running. AWS SCT, Schema Conversion Tool, helps convert your database schema, the table structures, stored procedures, etc., from one database engine to another. Super useful if you're migrating from, say, Oracle to PostgreSQL on RDS or Aurora.
Next up, task 3.5. Identify AWS network services. What are the key pieces for networking in AWS?
The foundation is Amazon VPC, Virtual Private Cloud. It's your own private, isolated section of the AWS cloud where you launch resources. Inside of VPC, you have subnets, rec tables, internet gateways, NAT gateways. For security within the VPC, you use network ACLs and security groups. Amazon Route 53 is the DNS service for routing traffic. CloudFront and Global Accelerator handle content delivery and traffic acceleration at the edge. And connectivity options like AWS VPN and Direct Connect link your on-prem network to your VPC.
We touched on VPC security with network ACLs and security groups before. Can you quickly contrast them again in the network context?
Sure. Security groups act at the instance level. They are stateful, meaning if you allow inbound traffic, the outbound response is automatically allowed. You only define allow rules. Network ACLs act at the subnet level. They are stateless, meaning you need explicit rules for both inbound and outbound traffic. They have both allow and deny rules, evaluated in order. They provide a broader layer of defense before traffic even reaches your instances.
Okay. And the purpose of Amazon Route 53?
Primarily, it's AWS's domain name system, DNS service. It translates human-friendly domain names like www.example.com into the IP addresses computers use. It's highly available and scalable. Route 53 can also do health checks on your application endpoints and route traffic away from unhealthy ones. It offers various routing policies like latency-based or geolocation routing.
And we've mentioned edge services like CloudFront and Global Accelerator, key networking benefit.
CloudFront reduces latency by caching content close to users via the CDN. Global Accelerator improves performance and availability by routing traffic over AWS's optimized global network backbone to the best application endpoint. Both leverage those edge locations.
Finally, networking connectivity. AWS VPN versus Direct Connect. When choose which?
AWS VPN creates a secure connection over the public internet. It's relatively quick to set up and cost-effective for moderate bandwidth needs. AWS Direct Connect provides a dedicated, private physical connection between your premises and AWS. It offers more consistent performance, potentially lower latency, and can be better for transferring large amounts of data regularly, but it's generally more expensive and takes longer to provision.
Let's move to storage. Task 3.6. Identify AWS storage services. Lots of options here too, right?
Definitely. The main categories are object storage with Amazon S3, simple storage service, super scalable, durable for almost any kind of data. Block storage for EC2 instances, which includes Amazon EBS, Elastic Block Store, for persistent volumes, and Instant Store for temporary, fast local storage. File storage like Amazon EFS, Elastic File System, for shared Linux file systems, and Amazon FSX for Windows or high-performance file systems like Lustre. And AWS Storage Gateway for hybrid cloud storage, connecting on-prem to AWS storage. Plus archival storage like S3 Glacier.
Okay, what are the main uses for object storage like S3?
S3 is incredibly versatile. Think website hosting, static files, backups and archives, data lakes for analytics, storing logs, distributing software, media hosting, basically anywhere you need to store large amounts of unstructured data reliably and cost-effectively.
We also need to know the differences in S3 storage classes. Why so many, and when use which?
They offer different cost points based on how often you access the data and how quickly you need it. S3 standard is for frequently accessed data, highest performance and availability. S3 intelligent tiering automatically moves data between tiers to save you money based on access patterns. S3 standard and frequent access, SIA, and one zone IA are cheaper for data you access less often but cost more to retrieve. And the Glacier classes, instant retrieval, flexible retrieval, deep archive, are for long-term archiving, super cheap storage, but retrieval takes longer or costs more. You pick the class that matches your access needs and budget.
What about block storage like EBS and Instant Store when used each with EC2?
EBS provides persistent volumes. The data stays even if you stop or terminate the EC2 instance. It's like a network-attached hard drive. Use it for boot volumes, databases, any data you need to keep. Instant Store is temporary storage physically attached to the host machine running your EC2 instance. It's very fast, but the data disappears if the instance stops, terminates, or fails. Good for caches, temporary files, data that can be easily recreated.
And file services like EFS and FSX?
EFS provides a scalable, shared file system primarily for Linux instances. Multiple EC2 instances can mount and access the same EFS file system concurrently. Good for web serving, content management, shared code repositories. Amazon FSX offers managed file systems tailored for specific needs, like FSX for Windows File Server, native Windows shares, or FSX for Lustre, high-performance computing.
The guide mentions cached file systems with AWS Storage Gateway. How does that work for hybrid setups?
Storage Gateway acts as a bridge. You deploy a virtual appliance on premises. It can present AWS storage, like S3, as a local file share, volume, or tape library to your on-prem applications. It often includes a local cache for frequently accessed data, making cloud storage feel faster for local apps, while the bulk of the data lives cost-effectively in AWS.
Finally, storage management, use cases for lifecycle policies, and AWS backup.
S3 lifecycle policies automate data management. You can set rules to automatically transition objects to cheaper storage classes like SIA or Glacier after a certain time, or delete them altogether. Great for cost optimization and compliance. AWS Backup is a centralized service to manage and automate backups across multiple AWS services, EC2, EBS, RDS, EFS, DynamoDB, and more. It simplifies backup scheduling, retention, and restoration.
Let's move into the exciting area of AML and analytics. Task 3.7, identify AWS AML services and analytics services. What are some key ones?
Yeah, lots happening here. For AML, the guide highlights Amazon SageMaker, which is the big, comprehensive platform for building, training, and deploying machine learning models. Also, Amazon Lex for building conversational bots, think chatbots or voice interfaces. And Amazon Kendra, an intelligent enterprise search service powered by ML.
And on the analytics side, services to help make sense of data.
Key ones include Amazon Athena, letting you run standard SQL queries directly on data sitting in S3 without loading it anywhere. Amazon Kinesis for processing real-time streaming data. AWS Glue, a serverless ETL service extract, transform, load for preparing data for analytics. And Amazon QuickSight, a business intelligence service for creating dashboards and visualizations.
The guide stresses understanding the tasks accomplished by these services, so not just the names.
Exactly. You need to know, for example, that SageMaker is for ML model development, Lex is for bots, Kendra is for search, Athena is for querying S3 data, Kinesis is for streams, Glue is for data prep, ETL, and QuickSight is for dashboards and BI. Matching the service to the job is key.
Now we hit task 3.8. Identify services from other in-scope AWS service categories. Sounds like a catch-all.
It kind of is. It covers important services that don't fit neatly into compute, storage, database, or networking. For application integration, you have things like Amazon Event Bridge for event-driven architectures, Amazon SNS, Simple Notification Service for PubSub messaging and notifications, and Amazon SQS, Simple Queue Service for decoupling applications with message queues.
Okay, what about business applications?
There's Amazon Connect, which lets you set up a cloud-based contact center quickly, and Amazon SES, Simple Email Service, for sending and receiving emails at scale.
The guide also lists customer engagement services. AWS Activate for startups, AWS IQ, AWS Managed Services, AMS, AWS Support.
Right. Activate provides credits and resources for startups. AWS IQ connects you with certified third-party experts for project help. AMS offers operational management of your AWS infrastructure, like outsourcing your cloud operations to AWS. And AWS Support provides the various technical support plans.
Then there's a long list of developer tools: App Config, Cloud9, Cloud Shell, Code Artifact, Code Build, Code Commit, Code Deploy, Code Pipeline, CodeStar X-Ray. What's the theme here?
Okay. This is all about streamlining the software development lifecycle on AWS. App Config for managing configurations. Cloud9 and Cloud Shell are cloud-based IDS shells. The Code Suite, Code Commit for Git repos, Code Build for building code, Code Deploy for deployments, Code Pipeline for CI/CD pipelines, Code Artifact for package management, CodeStar for unified project views, covers your whole DevOps workflow. And X-Ray helps trace and debug distributed applications.
What about end-user computing? AppStream 2.0, Workspaces, Workspaces Web.
These deliver desktops and applications to users. AppStream 2.0 streams desktop apps to any device. Workspaces provides full cloud-based virtual desktops. VDI. Workspaces Web offers secure browser access to internal websites without needing a full VDI.
For front-end web and mobile, we have AWS Amplify and AWS AppSync.
Amplify is a framework and hosting platform to quickly build and deploy full-stack web and mobile apps, integrating easily with back-end services. AppSync is a managed GraphQL service, simplifying data fetching for modern applications from multiple back-end sources.
And finally, IoT. AWS IoT Core and AWS IoT Greengrass.
IoT Core is the central hub in the cloud for connecting, managing, and securing IoT devices at scale. Greengrass extends AWS cloud capabilities to the edge devices themselves, allowing them to run Lambda functions, process data locally, and communicate even with intermittent connectivity. Okay, last domain. Domain 4, billing, pricing, and support, 12%. Still important stuff. First task, compare AWS pricing models.
Right, the guide lists a bunch of compute purchasing options: on-demand, reserved instances, spot, savings plans, dedicated host instances, capacity reservations. That's a lot. What are the main differences affecting cost?
Okay, quick breakdown. On-demand is pay by the hour second, no commitment, most flexible, highest price. Reserved instances, RIs give big discounts up to 72% for a 1 or 3 year commitment to a specific instance type or region. Good for steady workloads. Spot instances use spare AWS capacity, huge discounts, up to 90%, but AWS can take them back with short notice. Good for fault-tolerant, flexible workloads.
So RIs for commitment, spot for flexibility if you can handle interruptions. What about savings plans?
Savings plans are more flexible than RIs. You commit to a certain dollar amount of compute spend per hour for 1 or 3 years. You get RI-like discounts, but they apply more broadly across instance families, regions, even potentially across EC2, Fargate, and Lambda. Often a better choice than RIs now for flexibility.
And dedicated host instances and capacity reservations.
Dedicated hosts give you a whole physical server, mainly for software licensing reasons, BYOL or strict compliance. Dedicated instances run on hardware dedicated to your account but may be shared with your other instances. Capacity reservations let you pay to reserve capacity in a specific AZ, ensuring it's available when you launch instances, even without a long-term RI savings plan commitment.
The guide also mentions data transfer charges and different storage option tiers. How does pricing work there?
Generally, data transfer into AWS is free. Data transfer out to the internet is usually charged per gigabyte, and costs can vary by region. Transfer between regions also costs money. It's something to watch. For storage, pricing depends heavily on the service, S3, EBS, EFS, and the specific tier or class within that service, reflecting factors like durability, availability, and access frequency. Lower costs usually means less frequent access is expected or lower redundancy.
So when should I use these different compute options? General rules of thumb.
On demand for unpredictable short-term stuff or trying things out. R's or savings plans for consistent, predictable workloads where you can commit long-term. Spot for batch jobs, background processing, anything that can handle being interrupted. Dedicated options for specific license compliance needs. Capacity reservations for guaranteeing capacity for critical short-term events.
What about RI flexibility and how they work with AWS organizations?
Some RI flexibility exists, like changing instance size within the same family in some cases. Within AWS organizations, which lets you manage multiple accounts, the discounts from RIs and savings plans purchased in the master management account can often be shared and applied across linked member accounts, helping maximize your savings across the whole organization.
And just to reiterate, the difference between incoming-outgoing data transfer costs and the varying storage pricing. Key takeaway for cost management.
Be very aware of data transfer out costs, especially between regions or out to the internet. It can bite you. And for storage, actively choose the right service and tier based on how you actually use the data. Don't just default to the most expensive, highest performance option if you don't need it. Regularly review and optimize.
Okay, task 4.2. Understand resources for billing, budget, and cost management. What tools does AWS give me to track spending?
They give you quite a few. The AWS Management Console has a billing dashboard with detailed info. The AWS website has all the pricing information. The AWS Pricing Calculator helps estimate costs before you build. AWS Organizations allows consolidated billing for multiple accounts. And cost allocation tags are crucial. You label resources, like by project or department, and track costs based on those tags.
The guide specifically mentions AWS Budgets, AWS Cost Explorer, and AWS Billing Conductor. How do these help?
AWS Budgets lets you set spending limits and get alerts when you approach or exceed them. Helps prevent surprise bills. AWS Cost Explorer is a visualization tool to analyze your past spending, see trends, filter by service or tag, and forecast future costs. Really useful for understanding where money is going. AWS Billing Conductor is more advanced. It lets you customize your billing data for internal chargeback or showback purposes, maybe applying custom rates to different business units.
And the AWS Pricing Calculator, how do I use that effectively?
You use it before you deploy. You model your intended architecture, select the EC2 instances, RDS databases, S3 storage amounts, data transfer you expect, and it gives you an estimated monthly cost. It's great for comparing different approaches and getting budget approval.
How does consolidated billing and cost allocation work together in AWS organizations?
Consolidated billing rolls up all the bills from all accounts in your organization into one single bill for the management account. Simplifies payment. It can also pool usage for volume discounts. Cost allocation then leverages those tags you applied across all accounts, allowing Cost Explorer and reports to show you spending broken down by tag, for again by project, team, environment, across the entire organization. Gives you that unified visibility.
Finally, types of cost allocation tags and the AWS Cost and Usage Report. CUR.
You have AWS-generated tags, like ones indicating who created a resource, and user-defined tags, the ones you create. You have to activate tags for cost allocation. Once active, these tags appear as columns in the Cost and Usage Report, CUR. The CUR is the most detailed billing file you can get, listing every single line item of usage. With tags included, you can pivot and analyze this raw data very granularly using spreadsheets or BI tools.
Okay, let's wrap up with task 4.3. Identify AWS technical resources and AWS support options. Where do I go for help or info?
Lots of places. The main AWS website has tons of white papers, blogs, and detailed documentation. The AWS Support Center in the console is where you manage support cases. And the AWS Partner Network, APN, connects you with ISVs, software vendors, and system integrators who have AWS expertise.
The guide mentions specific technical resources. AWS Prescriptive Guidance, AWS Knowledge Center, AWS Repos. What are these?
AWS Prescriptive Guidance, formerly Cloud Adoption Framework Patterns, offers detailed patterns and best practices for specific solutions or migrations. The Knowledge Center is like an official FAQ database with answers to common technical questions. And AWS Repost is the official AWS Community Q&A forum, replacing the old AWS forums. You can ask questions and get answers from AWS staff and the community there.
What about the different AWS support options?
There's a free basic support level with access to docs and forums, then paid plans, developer, business hours email support, business, 24/7 phone chat, faster response times, some trusted advisor checks, and enterprise on-ramp enterprise, fastest responses, dedicated technical account manager, full trusted advisor checks, proactive support. You choose based on your criticality and budget.
The guide also mentions Trusted Advisor, AWS Health Dashboard, and the AWS Health API. How do these help with monitoring?
Trusted Advisor, as we said, gives recommendations on cost optimization, security, performance, fault tolerance, and service limits based on your usage. The AWS Health Dashboard shows you the current status of AWS services and notifies you about events that might affect your resources. The Health API lets you access that health information programmatically for integration into your own monitoring tools.
What about the AWS Trust and Safety team?
They handle abuse reports. If someone is using AWS resources maliciously, like for spamming or DDoS attacks, you report it to Trust and Safety, and they investigate and take action. Helps keep the platform clean.
And the role of AWS partners. What benefits do they offer?
The AWS Partner Network includes thousands of companies worldwide. System integrators help you design, build, migrate, and manage workloads on AWS. ISVs offer software solutions that run on or integrate with AWS. Partners bring specialized expertise, industry knowledge, and can accelerate your cloud projects.
Finally, AWS Marketplace, AWS Professional Services, and AWS Solutions Architects.
AWS Marketplace is like an app store for business software and services that run on AWS. Makes it easy to find, buy, and deploy third-party solutions. AWS Professional Services, ProServe, is AWS's own consulting ARM-paid engagements where AWS experts help you directly with complex projects. And AWS Solutions Architects, SAs, are technical advisors from AWS who work with customers, often pre-sales, to help design effective and cost-efficient solutions on the platform.
Wow. Okay, that was a really thorough deep dive into the AWS Certified Cloud Practitioner, the CLF-C02 exam guide. We've covered all 4 domains: cloud concepts, security and compliance, cloud technology and services, and billing, pricing, and support. We hit the key tasks and concepts in each. Hopefully that gives everyone listening a solid overview.
Yeah, absolutely. The goal was really to give you that strong foundation based directly on the exam guide so you know what AWS considers fundamental knowledge for this certification. It should give you a clear map of what's important.
And for those of you wanting to dig deeper into specific areas, remember the appendix of the exam guide itself. It lists many of the specific AWS services and features in scope. Definitely worth checking out based on what, caught your interest today or what you work with.
Yeah, and maybe something to think about as you process all this. How could having this foundational grasp of cloud concepts, security, the tech itself, and the billing side actually impact decisions you make in the future, even if you're not in a super technical role? Which of these areas really sparked your curiosity the most, and maybe what new questions do you have now? Sometimes those follow-up questions are the best outcome of a deep dive like this.